afternoon, ladies and gentlemen. My name is Arjan Meijer, and I'm going to talk to you about something that we come up with due to a visit at the plant of our customer. Is your plant ready to crash? And that was a question that popped up in my mind. We were visiting a customer on a assessment. We just walking through the field. We're expecting nothing, but just out of the blue, something Bluetooth connectable popped up. And we were in the middle of the field. I asked the company guy following me, what is this Bluetooth? What is it doing here? And actually it turned out to be that they ordered some big valves. It was a gas distribution plant, and they had valves like this big, so quite a lot of natural gas flowing through it. And actually they didn't think about the Bluetooth in it. They didn't order it because of the Bluetooth, but it was just in there. And at that moment I thought, well, is this plant now ready to crash? And why wasn't someone thinking about the Bluetooth in those valves? And that is what I would like to talk to you about. So first of all, a little bit of an agenda. Going to do a little bit of an introduction. Who am I? What is my background? The basics of cybersecurity management, which will be very quick because you're all experts yourself also. But I want to point out a few things because still that is the basic of cybersecurity. Some incidents that we've seen, and then about instrumentation, which are basically the wheels of an ICS system, and how to prevent basically your ICS system from crashing. So first of all, about myself. As stated, I'm the technical lead at Hudson Cybertech. I have a Bachelor of Engineering in Electrical Engineering. Experience in various security domains. Physical security I've done a little bit in. And also, of course, cybersecurity. And I'm also teaching a lot of ISA classes. ISA 99 or IEC 62443, as you like. And also the subject matter expert for ISA on the account. Well, and Hudson Cybertech is a solution provider on cybersecurity, and we focus only on the OT domain. So my basic day-to-day job is just going into plants and trying to secure them more better. So about the basics of cybersecurity management. What are the basics? Well, as everyone knows, technology, organization, and people. And those should work together. And why am I bringing this still up while you all have more than enough security knowledge yourself? Because when walking to the plant, I realized if a Bluetooth valve is inserted there without, well, their security management system catching it, and without them, well, having considered having Bluetooth on a valve could be an issue, then still those three pillars in some way need to be clarified more to that customer. So, and if we walk through our other clients and the assessments that we've done before, we see a couple of issues quite often. On the technology side, it's about network architecture. Not on the same side, but on another client. Well, ask, where are your network drawings, your basic network stuff? Oh, I don't have them. Why not? Well, basically, I can draw them up. It's just a straight line, and all the devices connected to it. And legacy systems that are there. Drawings and engineering, if they are there, they are often not current, not up to date. We see malware in the technical environments without them even knowing, on engineering laptops that have no antivirus on it. Dedicated systems and things that give you a false sense of security. If someone thinks, well, we have installed a firewall. Now it's secure. Now you should do a little bit more. You have to think about the other things, organization and people. That's also equally important. If we look on the organizational side, often we see a lack of vision. What is it that we want to do with cybersecurity? What is it what we want to achieve with it? No clear policy. Who was actually responsible for those valves that were implemented in the field? who has chosen them, and who was responsible for handling the cybersecurity at the instrumentation level. And just a quick show of hands, who of you here is actually an end customer which operates a plant or a... So a couple. Oh, that's quite good, actually. So, and then I'm curious, do you have defined at an instrumentation level also who is responsible and how am I going to handle cybersecurity in there? Often we also see no or not up-to-date procedures on how to handle things and a difference in culture if you vice versa it to the IT and the OT domain. And people, conservative culture. That's an interesting one. Any of you know Meijer, the television series? I think you all do, right? Okay. Actually, if we walk into an ICS environment, I use the comparison against Meijer. I mean, basically, what is the ICS environment? It's made to be 24/7 up, just running the plant. Second Christmas Day, plant has to run 24/7 up. So if there is an issue, much of what you see, an issue, ICS guys are running, getting the duct tape and the stick, and just fixing the issue. Like MacGyver, whatever the problem is, he just builds a tank out of a wooden stick and some duct tape. And those guys in the ICS environment generally are very, functionally driven. The plant has to run, so let's get on with it. It works. That's generally what we see, the thinking of the guys. And also a lack of awareness on both the management level and on a general level in the plant. Because what if a server fails due to a cyber incident or potential cyber incident? How are you going to handle forensics? Are you going to create an image to view what actually happened and to be able to check who was doing something? Well, not according to the normal operating procedures because, it has to function. So we're just going to reinstall the server as soon as possible, restore the backup and continue working. So, and on a couple of examples, what was the exciting edge there? Where did they fail? Well, for example, in refrigerators. I mean, the Internet of Things, we see a lot of devices also on the ICS environment, Industrial Internet of Things, as it used to be called, or is called. Technology-wise, a few presentations back, having a device with an open port in it, that you can just plain connect, get information in, and even change information. Another example, air capping can be much bigger than this, basically. So, but still, if you don't have the proper policies and procedures and not properly following how it should be done, then you might be infected. And on the other hand, people. If people open mails and so on, then you can be infected with some virus. So what is important that in every part of your cybersecurity, you take into account technology, organization, and people. Why? Because otherwise, you might end up being hacked. And that's also the same for the forgotten layers. And I'm happy to see discussions that I've had here already about devices, about instrumentation, about previous presentations we've seen. There is gaining a lot more attention to the lower levels, because what are the forgotten layers? Quite often we are talking about cybersecurity in a way like this on the levels 3 and the top of level 2. We are talking about securing our Windows host. We are talking about securing the networks on top of there. We are talking about securing, the users that use them. And those are all good measures. But what about the layers below that? The forgotten layers, the layer 2, the controllers, the low-level controllers, your remote I/O. your sensing equipment, sensors, your actuators. And that's basically how we got up to the story, because the valves with the Bluetooth on it, they belong in that level. They belong to the instrumentation level. And basically, if you look at instrumentation, it's, well, more or less the wheels of ICS. Sensors and actuators that are in the field, they help you move. They are like wheels, they keep your ICS in motion. They sense the road and they give you direction. If you want to go left, you turn the wheel and your wheels go around. Well, if you want to have more pressure in a valve, then you open, or more pressure in a tank, then you open a valve and more air flows in, for example. Basically, it translates where you want to go in movement. And they are absolutely needed for operation. How many plants would run without sensors and actuators? Well, not a lot. So they are critical for the correct operation. And issues can have severe consequences. And basically they can have you crashed. Ever tried driving your car and removing a wheel while driving? Probably, I don't know how they filmed it. Either someone was really at the right time on the right place with the camera, or they put it in scene. But anyway, without proper control over your plant and proper safeguarding of your lower levels, your instrumentation, you might end up in a situation that you're out of control and basically crashing. So what about those sensors and actuators? Well, we see sensors and actuators more and more being equipped with things like Ethernet IP, Profinet. Basically protocols that are TCP/IP based. And it's easy, right? You pick a cable, a J45 connector, you put it in and it's connected. It either has a manual IP or an automatic IP. And you can start operating your plant. However, if you look, for example, at the lower right corner, flow meter, nothing special about it, you connect it, it gets an IP address and it can communicate. But it also has a web server on it. And types of devices that you would see: flow meters, pressure sensors, temperature, motor controls. All those devices get TCP/IP based. They are having firmware in them, which has an Ethernet stack. They are connected and they provide you information and provide you control over your plant. But if then you have sensors in there with flow meters, and from the plant owners or what you know, how many flow meters are on an average plant? 100, 200, 300, depending on the sector of course, quite a number. Or any other sensor, or any other actuator. What if your supplier comes out and says, well, I need you to patch? How are you going to do that if you have like 1500 flow meters? Are you going to patch them all? Are you going to patch them one by one? And even then, how are you going to check whether or not the firmware is accurate? And how are you going to know the firmware that's currently in your sensors is actually the firmware that you intended, hasn't messed up, hasn't been modified? So basically, everybody talks about defense in depth. You should do something with, well, antivirus, with firewalls, and all the security measures that we all take. Defense in depth, in a broad sense, having multiple measures and making sure that they support each other and that you get a system that has technology, people, and organization working together to secure your product or your process. But there's also another defense in depth. And that's a defense in depth that goes literally in depth. That is literally going down into your plant. And what is important is that you already think of how are you going to integrate sensors and actuators that have those kind of capabilities. And how are you going to make sure that if you make a decision to use them, because if you decide not to use them, it's also okay. But how are you going to manage it? And who is managing it? So basically, how are you going to prevent your ICS from crashing? Because basically those sensors and those actuators, they provide you information. Like you have a tank, pressure sensor on it, and it measures the pressure in the tank. The tank should always be between 0 and 10 bars, because above 10 it will basically do boom. And you have heavy security on your Windows system, on your network, you check for intrusions, and so on. But then you have the small engineering laptop, and not really the engineering laptop for the process automation, but the configuration laptop for your instrumentation part, your instrumentation network. And somehow someone is able to mess with your sensor, because your sensor is actually the one that decides what is going to be read in your automation system. 0 to 10 bars, oh, that's equal to 4 to 20 milliamp. That's nice. So let's reconfigure the sensor. Change firmware, put malicious firmware in, or just really reconfigure it. Like, okay, well, 0 to 20 bars is now 4 to 20 milliamps. Are you be able to detect that on the higher levels? Perhaps, if you are looking at the laptop that is doing the configuration. But otherwise, your automation system will just say, well, 4 to 20 milliamps is 0 to 10, that's the basic configuration, so okay. I read 18 millibars now, or milliamps. What's the pressure? Well, it should be around 9 bars, some more or less. But if it's reconfigured or modified in some way, then it won't be 9 bars. It will be around 17, 18 bars, actually causing an explosion. And then you might have a safety system, and that safety system is safeguarding your plant from, well, having an issue. And in safety world, they have decided, well, if we have one pressure sensor, we're going to look at it, we're going to perform a heads-up, and we're going to say, well, there's a certain risk that the sensor might fail, or that the sensor might, well, be wrongly configured by accident. So, solution for that, we're going to implement another pressure sensor, 2 pressure sensors, to make the chance of them failing together smaller with an acceptable limit. That's a security approach. Does it do anything good for safety? Security? No. Why not? Because safety takes into account, well, something might happen by accident. While security, and sometimes, is about malicious activities. Someone on purpose doing something. And that's a whole different approach than looking just at safety. But if someone is deciding to do something to your plant and really is aiming at destabilizing your plant, he should do it at the instrumentation level. Why? Because if you can get there, those are basically the wheels of your ICS. They are really sensing your process. Those are the instrumentations that really sense what's the temperature, what's the pressure, what's the current flow. And if adversaries are able to manipulate that data, well, then probably everything that's at a higher level could be compromised. So, what could you do about it? Well, make sure that the defense in depth and the broad spectrum of measures that you're taking are also applied to the instrumentation level. Make sure that you think about who is responsible for. How are we going to manage the sensors, the actuators? And not only, because in the previous presentations there was a question who is actually responsible for maintaining. Well, if you look at the ISA 99 standard, or IEC, you have automation product developers. Those should have requirements, how to create secure products. How are you going to make sure that they're actually secured? Automation suppliers, system integrators, but also the end user itself. They all must work together to make sure that your plant keeps operating the way it is intended, and that your instrumentation level really does what it must do. So, then for example, if you look at the ISA 99, you're all familiar with ISA 99 or IC 62, okay. Well, that's good. Quite a number of people are. Well, actually there's something in there that says something about product development. How can we create secure products? And how can we create products that are less likely to be flooded with vulnerabilities? Not that it actually makes the product 100% secure, because that's not, well, feasible at all. But anyway, it looks something like this. It specifies that for your devices that you're going to employ in your production environment, first of all, you should do something with communication robustness testing and test whether or not it complies with normal TCP/IP. It complies with, well, not having unnecessary ports open. Then you also have a functional security assessment. Is what is specified about the device really implemented? And can you make sure that if it says, well, the device should have this, this, and this security capability, can you be sure that it actually has that security capability? And the next component is the software development security assurance. It's basically how are you going to develop your software? And that's something that need to be done all three at the vendor side. Someone who is creating a product. For example, in the software development security assurance, are you using secure coding? Are you doing code checking? Are you actually testing for security characteristics? Because in my opinion, if you are going to use, for example, a flow meter or a pressure sensor that is actually connected to TCP/IP instrumentation network, well, you should know how it is made. Was it created with also security in mind, or was it just a functional requirement in mind? It should measure pressure and it should put it out to the Ethernet. And why is actually a web server included in a flow meter? I don't know. Could be easy in some cases, but... And anyway, it's helping vendors because they can create a software development process that they can use across multiple products. And they can get certified by a number of labs in the world. And they can really help you, or help the vendor in this case, to create more secure products. So that's the vendor side of it. But for the end user side, well, for the people that know ISA 99, probably you've seen this already before, but it's basically the cybersecurity management system. Is it also applied in all your plants and in wherever you deem it necessary to the instrumentation level? Are you actually making sure that people that are working there also have a security awareness level? Because in that case, the client that I mentioned earlier, they had two departments. One was the process automation department. They had that security awareness training. They had security training. They know what cybersecurity was. The other department was E&I, electrical and instrumentation. Oh, electrical and instrumentation doesn't sound anything like automation, so why include them in the cybersecurity awareness trainings? I mean, basically all that's happening there is that we convert the pressure to a 4 to 20 milliamps, so that's an electrical part, so, right? No. You should be prepared to integrate also your instrumentation guys, E&I, and if they are the same department or not, but make sure they are also trained, that they also need to follow policies and procedures, and that you have requirements in place if you are going to buy a instrument, pressure sensor, flow meter, or whatever, to what cybersecurity policies of the organization should it comply? Who is responsible for the cybersecurity there? And it might be handy to check how we're going to handle things like patch management during system development and maintenance. Because if you find out that all your flow meters have a vulnerability in there, can be hacked and can be brought down, perhaps you want to patch. But when are you going to do that? A lot of chemical and oil and gas plants are on a 4-year on-off cycle. Every 4 years there's a major downtime, and then we can install a patch. So actually, if we just finish the maintenance and then the vulnerability is discovered, too bad. We're out of luck then. So, and what about network segmentation? Are you going to segment those sensors? Are you going to put them into specific network segment, firewall them, control traffic through them? Or are you going to put them straight into the same network segment as your PLC controllers, for example? Because the choices that you're going to make in the beginning will work out later on. Who of you actually have sensors that are currently now, or employing sensors that have TCP/IP connectivity? Who thinks that they will have sensors in the coming 5 or 10 years on TCP/IP? I think you all will, at some point, somewhere. Why? On another conference I got a question, but why should you employ TCP/IP? Well, in some cases it can be a legit business need. If you already have the cabling and the other stuff there, it can be a legit business need to use those cabling and to use network for connecting your instrumentation. How to decide? Well, you should do it risk-based. What is the additional risk versus the additional cost? And what is the best solution for your plant? But in some way, we all will have to deal with implementing sensors. And then it's about ownership, because those devices need to be owned. Well, generally you see that with the E&I department. Make sure they are trained. Make sure that your E&I department is up to speed about what you really want and what do you expect from the sensors. We had an interesting talk also that said, well, something about monitoring. If you look at the topic of the 4.6 conference, detect. Are your sensors actually going to send out logging who is connecting to them? Because that might be valuable information to check whether or not something might happen with your sensors. Or how are you going to even do, well, intrusion detection in a network? Let's say if in 10 years you have like 1,500 flow meters and a couple of hundred temperature sensors and some pressure sensors, and that's only the sensor level, and then actuators controlling a motor actually through TCP/IP. And yes, true, in ICS you have very predictable data patterns, like sensor A is always providing information to PLC B, and again, and again, and again. But still, how are you going to do that? Because how many TCP/IP nodes are currently in an ICS network? My opinion, not so much. But if it really comes through, and I don't know whether it's really going through with all the TCP/IP and playing it down to the instrumentation level, but if it is, then probably you will have more IP addresses on the instrumentation level than you have in the office IT. And you will need to have measures how to handle it. You will need to have a zoning and segmentation strategy to be able to cope with the amount of sensors. to make sure that your risk doesn't increase, or that at least it will be manageable. That you know what is going on in my sensor network. Is anyone trying to do any malicious communication or connections? And your patch management. Are you going to shut your plant down to implement patches for all your instrumentation? Or are you basically going to have a plant design that actually take that into account? That you have like multiple flow meters behind each other? Or are they going to make sure that you can apply patches on the fly? Then you're missing out on data. You're missing out on wheels for a couple of seconds or minutes. Can your plant survive that? Is it able to cope with losing the data? Is it able to cope with losing the availability to sense and to act and guide your plant? Because the uptime requirements down there, I mean, you really need to be up for 24/7. And the higher you go up in the food chain, in the levels, basically a SCADA system, can you run your plant for 5 minutes without a SCADA system? In most cases, yes. It's not preferable, but you go down into the plant, local HMIs, depending on the architecture and the config. But anyway, you will have to think about it. And what I hope to bring you in this presentation is how, in the future, if you're going to decide to cope with TCP/IP, do it on a conscious base. And if you're not sure how it's organized at the moment, go visit your E&I guys, the department that is responsible for that at the moment. Ask them, are you up to speed on cybersecurity? Do you know what's going on in your instrumentation? Do you know how cybersecurity is handled there? Because the reason that client had Bluetooth in the field, and actually in weak security settings, was because they just didn't know. They just ordered the valves that were physically fit for their plant. And by chance they happened to have Bluetooth on them. And that's a situation basically you don't want to be in. So make sure that you embrace standard and that you implement it in your organization. And what is important, stay in control. Make sure that you not have to react on what is happening after the event. But make sure you make clear policies, clear definition on what you want, the risk that you are willing to take, and how to handle if someone comes with a request. And then I would like to thank you for your attention. And I've seen some questions pop up, so.
Yeah, we start by giving you a warm hand. Thank you. I would like to show you this first before we. There's another question they have the possibility to vote for. It turns out that the standards you're talking about, a vast majority think it will increase the robustness of ICS and will increase the security awareness in OT. So it seems like it's a useful standard. Have you implemented it somewhere? Have you actually working with that standard?
Yeah. From my day-to-day job, basically, we try to use the standard quite a lot in how to guide an organization to implement cybersecurity. And by that we don't mean that we are going to create a piece of paperwork this big. And actually yesterday we had quite a funny practical case on how to implement an introduction to ISA 99. And what we've done there in just one day is in a network create a zoning and concept model and applying the ISA 99 to a ICS environment. And I think if you do it in a lean, good way and follow the standard and use it in a practical manner, you can really gain advantage of it. So I'm very pleased with the outcomes of
but that goes for more or less any standards. I mean,
absolutely.
they are useful as long as you know how to manage and implement it. So, but disaster recovery is a part of this standard or not?
Yeah.
It is?
Disaster recovery is part of the standard. And it's actually part in two pieces, like a business recovery and a cybersecurity recovery part. Because in some cases, business recovery, that's basically what it's all about. And I use generally the example of if you have a plant that is having a packaging machine for package food materials. And if it goes down for 2 hours, you have a business problem. What is your solution for that? And it really is in ICS about the business. And a solution might be not to do anything technical, but having a temporal worker agency, you call them up and say, well, I need 20 guys to pack my stuff into boxes and do it manually for the time that it takes to restore your equipment. So,
So I couldn't help thinking about one of the Dilbert comic strip. I tweeted it because what I hear you saying is that people are buggy. You cannot trust people. Dilbert was doing a root cause analysis, and I found the root cause of our troubles. It's people, and we have the point head manager sitting there, telling the board, the chair of the board, do you have a pen? Taking notes. People are buggy, and that's true. So when we talk about protocols, is it better to trust the old dedicated process control networks rather than migrate it to the new IP-based networks? What would you say?
That depends on the view. And I mean, basically that comes down to, at least in my opinion, what is cybersecurity? I would rather talk about cybersecurity as being business optimization. Cybersecurity should be part of the decision either to stay at the old protocols, having it hardwired, or using new TCP/IP protocols, because in some ways it can help you. And if you know how to handle the additional risk and really make conscious decisions about whether to stay at the old or go to the new, that is what it's all about. It's not either having the new or the old, but it's about making conscious decisions and being aware of the risk you're taking.
Okay, so another question was, why can't you use ISO 27000 series on the OTs?
You can, basically, but it's about using the right tool. And actually in a presentation I gave yesterday on the workshop, there was a slide in there, and it's like putting a nail into wood. You can do that either by a steel hammer, which is made for it, or by a rubber hammer, which is not made for it. Eventually you will get the nail into the wood.
Yeah, but if a hammer is all you have, that is a nail.
Yeah, that's true. But actually what the question, we get it quite often. Why are we using ISA 99 or IEC and not ISO, because that's already implemented in the IT? True. What we do at the moment currently is involve the NIST US framework. They have a framework in which all the standards are mapped. And we use the NIST framework as an overall communication view to management. That we say, well, okay, these are the 5 categories defined in your NIST framework. How is it implemented in IT? And then you have a mapping to the ISO. How is it implemented in OT? And then you have the implementation to the ISA standard.
Okay.
And then you can use them both together in your organization while still having an overall KPI measurable security system.
But will there be a risk that you have different pipes working in parallel rather than working together?
The risk is there, but you should manage it in a way, and that's something that ISA in its standard also clearly say. If you're going to create a work team to implement the ISA 99 in an organization, you should involve people from operations, you should involve people from engineering, you should involve people from quality, but also from IT and IT security. Why? Because they have specific knowledge of what is currently there. And you should not throw out all all the things that you have. But as an example, you can use a policy that is used in IT. You can take it and adapt it. And one of the adaptations, if you're going to look on the main difference between IT and OT on policy-wise, for example, it's about exception management. If you look at an IT policy that says something about antivirus, it says, well, this is how we're going to do antivirus within the company, it's always up to date, and this is it, period. Well, sometimes in the OT environment, that's simply not feasible, it's not workable. So then it's very important to have a exception management, that someone reads there, oh, if you cannot comply, please call to the following number and we will help you be compliant or get an exception in or make a decision at least.
That's a great idea. I mean, it's more or less always the case that a policy is a policy and there will be acceptances that you have to manage, as long as you know what you're doing.
Absolutely, and that's what it's all about.
Thank you very much.
Perfect.